continuation of learning systems design. Today we'll study about designing product layouts. We begin with line balancing. So whenever a product, like I have been speaking about products and services earlier too. Whenever a product is manufactured, you have to arrange workers and machines in a sequence in which the operations have to be performed. So you call these sequence as a production line or an assembly line. And the main thing in this would be how can you balance these lines. Now, okay, as an example, like these lines can be very long or they can be very small. Example of a long line would be a Ford Mustang. Like the production of a Ford Mustang, it requires to travel 9 miles from the start till the end. And after traveling that 9 miles, you have a Ford Mustang. But suppose you send that Ford Mustang for servicing after using it, or say just for a car wash. So it just goes through scrubbing, rinsing, drying. So that would be an example of a small line. So in these lines, as we see, there are various activities to be performed, or operations to be performed, or tasks to be performed. Now, suppose for each task you assign just one worker. Do you think it's a feasible thing to do? I mean, you have various tasks to be performed, right? In making of a Ford Mustang, you have various tasks to be performed. So if you assign just a single worker for each task, it's going to be very infeasible because you'll have to have many workers. At the same time, it's not even there may be some moral hazards, like one worker may be working throughout the day and the other worker is just sitting up. So what you need to do is you need to group these tasks and then group these tasks into workstations. And the next thing would be to balance the time in each of these workstations. So that's what we'll study here about line balancing. Balancing the time in these workstations. So what's line balancing? It's a process of assigning tasks to workstations so that each has approximately equal time requirements. Now what you see here are, say, 5 tasks, and the minute for each, the time required for each task are as shown here. Can you see this actually? Okay. So by grouping these tasks into workstations, we can achieve maximum labor and equipment utilization. Because suppose there was one worker working at each of these tasks. The worker at 1 minute, he'd be busy all the time, and the worker who's working here, he just requires 0.1 minute to do this task, right? So if you can group these tasks, you'll achieve maximum labor and even equipment utilization in terms of, say, machines, if machines were performing these tasks. So that's why we see it's so important to group these tasks. And then it will even ensure a smooth flow of work. It will minimize the idle time. At the same time, about the model problem I spoke, all workers are equally given equal amount of work to be performed. So that's why we see it's so important to do line balancing here. But how do you achieve it? I mean, do you think it's so easy to group these tasks into workstations? What could be at least one reason that would come to your mind in grouping these tasks to workstations?
Very big problem will be the input-output dependencies. So for example, one particular task requires something else to be done.
Right.
You have to wait till that particular task.
Right. You're talking about precedence relationships, right? Suppose I spoke about servicing of a car, just a car washing thing. You need to scrub, rinse, and then dry. So, and suppose scrubbing and drying takes 2 minutes, but rinsing takes 4 minutes. But in no ways can you club the scrubbing and drying, right? Because you have to go through the rinsing process. So there is this precedence relationship which has to be maintained when you group. And then there are various interdependencies also which you have to be careful about. So we'll see how we can group these tasks. For that we consider the cycle time. So cycle time is the maximum time each workstation is allowed for completion of its set of tasks on a unit. And the maximum cycle time will be the sum of all the tasks. If tasks in the same workstation, if this was one workstation, then the maximum cycle time would be an addition of all these times. And the minimum cycle time will be the longest task time if each task is one workstation. So you just see that. So suppose in this case what we have done is now each task is a workstation. I mean each task is assigned to one workstation So with which makes 5 workstations, and we'll have the cycle time of 1 minute, right? That's the maximum time required across these tasks. So the cycle time would be the longest processing time, not the maximum time, but the longest processing time in a workstation. Suppose this was one whole workstation, then the cycle time would be 2.5 minutes. You just add all of the tasks. And if we had say 3 workstations, then we have a cycle time of 1 minute, right? So is it really possible to complete the task in 1 minute? There may be some inefficiencies which may which will make the cycle time go higher, right? But you have a lower bound and an upper bound. Your cycle time, it cannot go below 1 minute, of course, but it will always fluctuate between 2.5 minutes and 1 minute. So once you know the cycle time, you know how much quantity you can produce, right? Because cycle time is nothing but, like say if the cycle time is 2 minutes, then you know that at the rate of every 2 minutes you're producing one product. So once you know the cycle time, you know how much quantity you can produce. So the output capacity would be the operating time per day and divided by the cycle time. So suppose you have 8 hours per day, that will give you 480 minutes per day. And if you have a cycle time of 1 minute, you'll be producing 480 units. But if the cycle time is 2.5 minutes, you'll be producing 192 minutes. 92 units per day. Sorry.
Can you go back on this? So how did you find cycle time for second one is 1 minute? Because the middle one is 1 minute?
Yeah, if you add these, this is 0.8, this is 1, and that's 5, 6, 7.7. So the maximum is
cycle.
Maximum, yeah.
So you are assuming that these 3 tasks can be done parallelly, so there is no physical pressure?
No, they just go in sequence. First it has to be done at workstation 1, then 2, and then 3. It's a sequence.
It's a sequence, and why are you adding it? Then what is cycle time? Why didn't you get them?
Okay. See, suppose this is your whole system. Your product has gone in from here, right? And it will come out at the other end. Now, when the product is being worked on over here, it will take 0.8 minutes. When it comes here, it will take 1 minute. When it comes here, it will take 0.7. Now when product A has come here, right, at the second workstation, suppose we have 2 products, A and B. When product A is here, that MB is waiting. When product A is at workstation 2, product B is being processed here, right? When product A goes to workstation 3, product B will go to workstation 2. The bottleneck here is is a workstation 2. Imagine this to be a black box, right? Just the product is going in and it's coming out. You do not know what's going in here. Now this is the bottleneck. Meaning to say, whenever a product comes out, there is another product being processed at each of these workstations. I could have shown through an Excel file. If you just simulate the products going in and coming out, you will see that the products come out at a difference of
you're
1 minute.
the idle time of the machine. Say, for example, every block in a machine.
Yeah.
So this first two machines is like one workstation.
Right.
So, and the middle one is another machine which is having, say, only one workstation is just having one machine, and the last block is having again 2 machines. So it's like you freed up the first block and you put your product A to the second block, so
Right.
the first block is free.
Yeah.
So you can utilize the machines for some other product in parallel to the first product which is going in second workstation.
Okay, if that, oh, yeah.
So it's like you're breaking up the whole line into some segments which can be utilized in parallel for
Okay,
two different.
fine, yeah. What I thought you would mean is, say, suppose product A is being done there, product B is here, like parallelly, oh, okay.